Hello everyone, once again welcome to MPLS series. In this video of MPLS, again we are going to discuss IPv6 over MPLS. This is second video of IPv6 over MPLS. Today we are going to use method 6VPE. 6VPE stands for IPv6 VPN, virtual private network, and P stands for provider edge. So IPv6 virtual private network provider edge router, provider edge you can say, right? Or this is nothing but IPv6 L3 VPN. This is nothing but IPv6 L3 VPN. You can say 6VPE is IPv6 L3 VPN. So today again we will exchange VPN v6 prefix over MPLS. As you can see in this scenario, I have four side of same customer A side 1, this is customer A side 1, this is customer A side 2, this is customer A side 3, this is customer A side 4. Inside one of customer A, you can see we have IPv6 network, only IPv6 network, right? Inside two of customer A, we have dual stack IPv4 as well as IPv6. We have IPv4 network as well as IPv6 network. Inside three of customer A, again this is dual stack side IPv4 plus IPv6, and inside 4 we have only IPv4 network, right? So we need to exchange VPN v6 prefix over MPLS today by using 6VPE method. 6VPE method. Before discussing anything, I want to discuss this topology first. In this topology, as you can see, in service provider we have 5 routers, and router 5 is my route reflector. Router 4, router 2, router 3, and router 4, these 4 routers are provider edge router. And here we are running OSPF as a IGP protocol, MPLS and BGP, MPBGP, right? Like between router 1 and router 5, and between router 5 to router 4, router 5 to router 3, router 5 to router 2, right? Like this. And I have already configured OSPF and MPLS in this scenario. First of all, let me make you understand the reachability. Let me show you the reachability between loopbacks. From router number 1, I am going to, let's say, ping other loopback which is running on router number 2, let's say 2.2.2, 2.2.2.2, and say source is 1.1.1.1. So yes, these two loopbacks are reachable with each other through OSPF routing protocol, and ping 3.3.3.3, and source is again 1.1.1.1. This loopback is reachable through OSPF, and ping 4.4.4.4, and source is 1.1.1.1. So you can see all loopback are reachable with each other through OSPF. You can configure any IGP protocol in service provider network. After that, I have already configured MPLS. So you can see, so MPLS LDP neighbor, so router 1, so MPLS LDP neighbor on router number 1, I think MPLS is not enabled. So MPLS interfaces. So MPLS is enabled on fast Ethernet 0/0. I think MPLS is not enabled on router number 5. Let me check router 5. So MPLS interface. So yes, MPLS is not enabled on router number 5. So first of all, let me configure MPLS here. Router OSPF, I am running process 1, say MPLS LDP auto config, right? And now you can verify the MPLS LDP neighbor from router number 1. So MPLS LDP neighbor. Now if I will run this command, so you can see 5.5.5 is neighbor, means router number 5. And on router number 5, if you will run so MPLS LDP neighbor, so MPLS LDP neighbor, so you can see router 3 is neighbor, router 1 is neighbor, and router 4 is neighbor, and router 3 is neighbor. Where is router 3? Router 3 is neighbor, router 1 is neighbor, router 4 is neighbor, and router 2 should be the neighbor. Just wait for some time. I think MPLS is not enabled on router number 2 also. Let me check R2. So MPLS interfaces. So yes, here also MPLS is not enabled. Let me configure MPLS router OSPF process 1 and MPLS LDP auto config. Now in service provider network I have enabled MPLS on all WAN interface. On router number 5 you can see now, so MPLS LDP neighbor, so router 3, router 1, router 4 and router 2, right, router 2. So MPLS OSPF is already configured. We are going to configure BGP. First of all we will configure service provider network, then we will configure BGP between P to CE router. Okay guys, in service provider network also you can see between router 1 and router 5 we don't need to configure VPN v4. Here VPN v4 is not required because router 1 is P router and this P router is connected with a CE router, and here router 6 is using only IPv6 address. So router 1 is not going to advertise or receive any VPN v4 prefix from their neighbor router 5, right? So we will not configure VPN v4 between router 1 and router 5. Between router 2 and router 5, as you know, I here router 7 is using both. It is dual stack. So between router 2 and router 5 we will configure VPN v4 also and VPN v6 also, right? In the same way between router 3 and router 5 also we will configure VPN v4 as well as VPN v6, and between router 5 and router 4 we can configure VPN v4 only, because here router 4 is not going to receive or advertise any VPN v6. Okay, here because router 4 is connected with router number 9 and router 9 is using only IPv4 network. So here I have command in router number 1. See what command I am going to run. Route, first of all I am going to enable IPv6 unicasting, because if IPv6 unicasting is not enabled you cannot activate the neighbor for VPN v6. Okay, so you cannot activate the neighbor for VPN v6. That's why first of all I will run IPv6 unicast routing. After that router BGP 65000. In this service provider network I am running BGP 65000, and in customer side we are running BGP 100. Okay, after that no BGP default IPv4 unicast. You can ignore this command if you want, otherwise you can run it. We have already discussed this in previous video. After that neighbor 5.5.5 remote AS 65000. This command is also similar like previous video. Then neighbor 5.5.5 update source loopback 1, right? This is also the similar command like previous video. And after that here, instead of saying address family IPv4 we are saying VPN v6. Instead of saying address family VPN v4 we are saying address family VPN v6 unicast. For VPN v6 we are going to activate this neighbor, not for VPN v4 today. Okay, so this is configuration of router number 1. Let me copy this configuration and let me paste this configuration in the console of router number 1, and hope this configuration is clear to you. I have only one change here. Instead of VPN v4, you know, earlier you were activating the neighbor in VPN v4, and today we are activating the neighbor in VPN v6 for IPv4. Okay, wait, this is the configuration of router number 1, right? It's in service provider network. After that router number 2. On router number 2 you can see first of all I am enabling IPv6 unicast routing, then router BGP 65000. That is fine. After that neighbor 5.5.5 remote AS 65000, neighbor 5.5.5 and update source loopback 1. And here we are going to activate this neighbor for both VPN, for VPN v4 also and for VPN v6 also. So address family VPN v4 neighbor 5.5.5 activate, and address family VPN v6 neighbor 5.5.5 activate. Right, this is configuration of router number 2. Here I have advertised activate neighbor 5.5.5 for both VPN, for VPN v4 also and for VPN v6 also. Let me copy this part of configuration and let me paste it in the console of router number 2. This configuration is very simple and similar like previous video. There is only one change. After that on router number 3, again router 3 is connected with dual stack. So here we will activate neighbor 5.5.5 for both VPN v4 also and for VPN v6 also. So IPv6 unicast routing, and then router BGP 65,000, neighbor 5.5.5, remote AS 65,000, neighbor 5.5.5, update source loopback 1, and address family VPN v4 unicast, neighbor 5.5.5 activate. Also address family VPN v6 unicast, neighbor 5.5.5 activate. Right, so here I have activate this neighbor for both VPN. Let me paste this configuration in the router 3 console. Router 3 console, very good. Okay, after that finally router number 4. On router number 4, router 4 configuration is exactly same like IPv4 sorry, L3 VPN. Okay, so here we have only IPv4 address, so we are activating this neighbor for VPN v4 only, not for IPv6. So let me copy this part of configuration here and let me paste it on router number 4. Right, configuration on router number 4 is similar like IPv4 L3 VPN, right? And actually this topology is combination of IPv4 L3 VPN as well as IPv6 L3 VPN. Okay, now on router number 5. On router number 5, you can see first of all we will enable unicasting. After that no BGP default IPv4 unicast, then neighbor 1.1.1, neighbor 1.1.1. With this neighbor we are going to activate VPN v6. We are going to activate VPN v6. So first of all I am defining the remote AS and update source loopback with all neighbor. Getting my point? Still here you can see neighbor 1.1.1 remote AS 65,000, neighbor 1.1.1 update source loopback 1, neighbor 2.2.2 remote AS 65,000, neighbor 2.2.2 update source loopback 1, neighbor 3.3.3 update source loopback 1 and remote AS 65,000, neighbor 4.4.4 remote AS 65,000, and neighbor 4.4.4 update source loopback 1. And after that you can see actually these loopback, I am running these loopback on loopback 1 interface. And after that you can see for IPv4 I am going to activate these three neighbor: router 2, router 3 and router 4. Router 2, router 3 and router 4, not router number 1, because here as I told you that router 1 is not going to receive or advertise any VPN v4 prefix. So I am not activating 1.1.1 for for VPN v4. And after that, as you know, router 5 is route reflector. So these are the command, right? Neighbor 2.2.2 route reflector client, neighbor 3.3.3 route reflector client, neighbor 4.4.4 route reflector client. So I have run these command inside the address family VPN v4. In the same way, inside the address family VPN v6, we are going to activate some neighbor like router number 1, router number 2 and router number 3, not router number 4, because router 4 is again not going to advertise or receive any VPN v6 prefix. Okay, like router 1 is not going to receive or advertise any VPN v6 prefix, router 4 is not going to advertise or receive any VPN v4 prefix. So that's why here in address family VPN v6 unicast I am activating 1.1.1, 2.2.2 and 3.3.3 only. After that route reflector client with this neighbor 1.1.1 route reflector client, neighbor 2.2.2 route reflector client, neighbor 3.3.3 route reflector client. Okay, so this is the configuration of router number 5, guys. Hope it is clear to you. See, for both VPN v4 or VPN v6 you have to run route reflector client command. Okay, now let me copy this part of configuration here. This is the only configuration of router 5. Copy and let me paste it on router number 5. And after running this command I am expecting BGP neighborship between router 1 and router 5, router 2 and router 5, router 3 and router 5, router 5 and router 6, right? So just wait for some time. After that I am going to show you the BGP neighborship also. Here on router number 5 we can check the neighbor. So on router number 5, so BGP VPN v4 unicast all and summary. For VPN v4 there are three neighbor, right? Router 5 have three neighbor: router 2, router 3 and router 4, not router number 1, right, for VPN v4. And in the same way, if you will check, so BGP VPN v6 unicast all summary. So you can see for VPN v6 we have three neighbor: router 1, router 2 and router 3, not router 5, right, for VPN v6. For VPN v4, these router 2, router 3 and router 4 are neighbor of router number 5. For VPN v6, router 1, router 2 and router 3 are neighbor of router number 5. Okay, so neighborship is fine here. Till now configuration is okay, everything, and it is easy. Now let me configure p to c router, p to c router. So on router number 1, I will start configuration from router number 1. On router number 1, again I am going to enable first of all unicast IPv6 routing, because here you can see uh, router 1 is connected with router number 6, which is using IPv6 network, and between router 1 and router 6 you have to run IPv6 address. Guys, you know to exchange VPN v6 prefix over MPLS, service provider don't need to upgrade their entire network, because in their entire network there are multiple routers, maybe 1,000 number of router or 2,000 number of router, so they cannot upgrade their network from IPv4 to IPv6, right? Just service provider need to upgrade edge router, provider edge router. Like on provider edge router, like on router number 1, they have to configure IPv6 address on fast ethernet 1/0, which is connected with customer edge, right? So between router 1 and router 6, I am going to configure this IPv6 address 2001 colon db8 colon 1 colon 6. 1 means router 1, 6 means router 6. So between router 1 and router 6, I am running this network, and double colon 0/64. Okay, so on router number 1, first of all I have enable unicasting IPv6 unicast routing and IPv6 unicast routing, because here without running IPv6 unicast routing you cannot run this command, right? So first of all you will enable IPv6 unicast routing. After that you will create one VRF here. As you know, I need to configure one VRF, so I am using the newest method to configure VRF over here. VRF definition A1, VRF definition A1, RD value is 1:1. I am going to define same RD value in all customer, in all side. For all side we are going to define same RD value. And address family IPv6, address family IPv6 route target both 100:100. Earlier here you were running command address family IPv4, right? But here today I am going to define route target value both for address family IPv6. So here I have create one VRF. After that I have defined RD value and route target value. Now you understand how we will define route target value for IPv6. Okay, after that interface fast ethernet 1/0, which is connected with CE router. VRF forwarding A1, I have assigned this interface to VRF A1. After that IP address, so IPv6 address 2001 colon db8 colon 1 colon 6 double colon 1/64. This is the IP address of router 1 interface. Okay, so here I have defined the IPv6 address, then no shutdown, no shutdown. After that router BGP 65000 and address family IPv6 unicast VRF A1. Earlier you were running command address family IPv4 unicast VRF A1, and today we are running this command address family IPv6 unicast VRF A1, because I am going to configure BGP neighborship between router 1 and router 6 with IPv6 address, right, not with IPv4. So address family IPv6 unicast VRF A1, and the neighbor, this is the IP address of router number 6 2001 colon db8 colon 1 colon 6 colon double colon 6 and remote AS 100. As I told you that inside the customer network we are running BGP AS number 100. Okay, after that same command AS override, and for IPv6 you have to activate the neighbor. For IPv4 neighbor is activated automatically, but for IPv6 you have to activate it manually. So that's why I have add this command here. Okay, this is the configuration of router number 1. See, let me revise the configuration once again. First you will configure the VRF. After that you will define route target value for IPv6, and then router BGP 65,000 and address family IPv6 unicast VRF A1, not IPv4 IPv4 unicast VRF A1. Okay, so here I have changed from IPv4 to IPv6, and these are the same command, and I have add this new command because for IPv6 you have to activate the neighbor manually. Now let me copy this part of configuration and let me paste it on router number 1. On router number 1, here is router 1, paste the configuration. Okay, I don't have any error, that means all command is correct. Now I am going to configure router number 6. First of all, we will configure this side 1 of customer A, then we will configure side 2 of customer A, then we will configure side 3 of customer A, and then side 4 of customer A. So let me take you to router 6 configuration. Here I have paste this all configuration on router number 1. Yeah. Okay, now on router number 6 you can see fast ethernet 0/0. I have defined simply IPv6 address here from the same subnet. So I have defined 2001:db8:1:6:6/64. This 6 is representing the router number, and this 1 is representing router 1, and this 6 is representing router number 6. After that I have one loopback. I have created one loopback, and on that loopback I have defined one IPv6 address. You can consider this as LAN network. Okay, this is a LAN network 2001:6/128. Okay, so this is simply IPv6 configuration over here. After that, IPv6 unicast routing, router BGP 65,000, and BGP, as you know, on router number 6 I don't have any IPv4 address, so you have to define BGP router ID. You have to define BGP router ID because we don't have any IPv4 address, and BGP router ID is representation in the form of IPv4. So BGP cannot elect any IP address, any IPv4 address as their router ID. So manually you have to define BGP router ID here. Then neighbor, this is the IP address of router number 1, 2001:db8:1:6:1, and remote AS 65,000. After that, address family, as I told you that you have to activate the neighbor in case of IPv6. So this is the not concern of IPv6 over MPLS. This is concept of BGP, that whenever you will configure BGP for IPv6 you have to activate the neighbor in address family IPv6 unicast. So I have here activate neighbor router number 1, and then I have advertised this network 2001:6/128. This is configuration of router number 6. Let me copy this part of configuration and let me paste it on router number 6. After running this command, I am expecting BGP neighborship between router 1 and router 6. So let me check what is the issue. Config T. I think here I have select something wrong. From here I am going to select it and let me paste it again on router number 6, and this time it's working fine. We don't have any error. That means all command is correct. Now wait for some time, you will see there one BGP neighborship will come up. Yes, here you can see the log message BGP, and you can check the BGP table here. So BGP IPv6, you can see in BGP table it have added this network 2001:6/128, right? And if you will verify the neighbor, so BGP IPv6 unicast and summary, you can see neighborship is also fine between router 1 and router number 6. And this time if you will check router 1 BGP table now, so BGP VPN v6, I am going to check VPN v6 BGP table. So BGP VPN v6 unicast all. So yes, it have received one network 2001:6/128. So router 1 have received this network from their neighbor, and after that router 1 will advertise it to their neighbor, means to router number 5. So let me show you the BGP table of router 5 also. So BGP VPN v6 unicast all. Here also you can see router 5 have received this network, right? 2001:6/128. That is fine, perfect, right? Still here configuration is easy. And in fact entire configuration is easy, right? Similar like previous video, only few changes are there. Now we are going to configure router 2 and router 7, means side 2 of customer A. Inside 2 of customer A, here again you can see which network I am running between router, which IPv6 network I am running between router 2 and router 7. This one, this is the network, IPv6 network between router 2 and router 7, and we need to use one IPv4 network also. So let me use 27.1.1.0/24. So okay, so on this interface and on this interface we will configure both IPv6 address and IPv4 address, because this is dual stack. Okay, now on router number 2, first of all on router number 2 we have enabled IPv6 unicast routing. Then we need to create VRF IP for side 2. I am creating VRF A2. VRF definition A2, RD value 1:1, and IP address family IPv4. For IPv4 we have defined this route target value, and for IPv6 also we have defined same route target value. For both IPv4 and IPv6 we have defined same RD value. Okay, after that interface fast ethernet 1/0, which is connected to router number 7, VRF forwarding A2, and then IP address 27.1.1.2 255.255.255.0. This is IPv4 address, and then IPv6 address 2001:db8 :2:7 :2/64. Here we have defined one IPv6 address also. After that router BGP 65000, and then address family IPv4 unicast VRF A2. This is for IPv4 unicast VRF A2, right? For IPv4 configuration. And in IPv4 neighbor 27.1.1.7 remote AS is 100. 27.1.1.7 is the IP address of router 7 on fast ethernet 0/0. After that neighbor 27.1.1.7 AS override, and here we don't need to activate the neighbor, automatically neighbor will activate. But in case of address family IPv6 unicast VRF A2, again neighbor is this time IPv6 address, and remote AS is same 100, and neighbor the IP address of neighbor, and then AS override, and then neighbor IP address of neighbor activate. So this is configuration of router number 2. Let me copy this part of configuration. See, on router number 2 I have define the neighbor command with both IPv4 unicast VRF A1 as well as IPv6 unicast VRF A2 in address family IPv4 as well as address family IPv6. Okay, let me copy this part of configuration here. This is advanced things, guys, advanced VPN, MPLS VPN. So on router number 2, let me paste this command, and let me check is there any error. No, we don't have any error here. That means all command is correct. Now let me configure finally router number 7, and after configuring VRF on router number 2, you can check that router 2 have received one prefix from their neighbor from router number 5 or not, which router 6 is advertising 2001:6. So BGP VPN v6 unicast all. So yes, you can see I have router 2 have received this network. Router 6 is advertising it. Router 6 will advertise it to router number 1. Router 1 have one VPN v6, one VPN v6 between router 1 and router 5. So router 1 will advertise it to router number 5, and router 5 will advertise it to router number 2, because again we have one VPN v6 between router 2 and router 5. So on router number 2 you can see router 2 is getting this network information, right? And if you will check, so IP route VRF A2 in the VRF A2 routing table also, sorry, so IPv6 route VRF A2, so IPv6 route VRF A2, so you can see it have install inject this network in VRF A2 routing table. And when BGP neighborship VPN v6 neighborship will come up, sorry, BGP neighborship for IPv6 will come up between router 2 and router 7. Router 2 is going to advertise this network to router number 7 also. So now finally let me configure router number 7. This is the configuration of R7. On R7, just I have defined the one IPv4 address and one IPv6 address on fast Ethernet 0/0. After that, again on loopback 1 interface, I have defined one IPv4 address and one IPv6 address. Because this is dual stack, you can create different loopback interface also, but I have created same loopback interface. On same loopback interface, I have defined both IP address, both type of IP address, IPv4 as well as IPv6. Then BGP configuration is similar like router number 6, and as you already know the configuration of IPv4, BGP IPv4. So IPv6 unicast routing, then router BGP 100, then neighbor 7.7. Router ID is 7.7.7. Here, if you want to remove this command, you can remove, because here we have IPv4 address, so we don't need to define BGP router ID. If you wish, you can define it. Then neighbor 27.1.1.7 remote AS 65000, that is fine, and neighbor IPv6 2001 DB8 27:2 and remote AS 65000. This is IP address of router 2 fast Ethernet 1/0, and then network 10.1.1.0 mask 255.255.255.0. This is for IPv4. You can define network like this, but for IPv6 we cannot define. Actually, there is one command, that is address family IPv4 unicast. This command is running there, right? This command. So actually, when we are running this command, by default in router BGP 100 mode, that means we are running it for IPv4 only, right? So you can skip this command also here, and you can put this command also. Let me remove this command from here. Then address family IPv6 unicast, and this time I have to activate the neighbor manually. So I have activate the neighbor. This is the neighbor IP address and activate. After that, I have advertised this network 2001:7/128, which is the loopback IP address on router number 7. Okay, this is configuration of R7. Let me copy this part of configuration here, and let me paste in the console of R7. After running this command, I am expecting two BGP neighborship between router 2 and router 7, one for IPv4 and one for IPv6. So BGP, so IP BGP, or we can say so BGP IPv4 unicast summary. So yes, 27.1.1.1 is neighbor, and we can say so BGP IPv6 unicast summary. So you can see one more neighbor we have, this one, and it have received one IPv6 address network from their neighbor. Receive prefix is 1. But for IPv4, it have not received any network, right? Because router 2 don't have any IPv4 network in VRF A2. They have one router number 2 have one network, IPv6 network in VRF A2. So it have advertised it to router number 7. And router number 7, if you will check BGP table, so BGP IPv6. This is BGP table. In BGP table, there is two network. This is receive prefix, and this is self-advertised prefix. This is self-advertised prefix. Okay, so it will advertise, router 7 will advertise this network to router number 2. On router number 2, if we will check BGP table now, so BGP VPN v4 unicast all. So you can see, sorry, this is IPv4. This is the BGP table for IPv4. Here it have received 10.1.1.0/24 from router number 7 from 27.1.1.7. and if you will check, so BGP VPN v6 unicast all, you can see it have received this network from router number 5 and this network from router number, sorry, this lower network from router number 7. Okay, and it will advertise this network to router number 5 also. So let me show you router number 5. So BGP VPN v4 unicast all, not VPN v4. In VPN v4 we have one network 10.1.1.0/24. You know this very well. VPN v6, and you can see in VPN v6 it have received two network now, right? One from router number 1 and one from router number 2. Okay, and on router number 2, or sorry, on router number 1 also we can check. So BGP VPN v6 unicast all. So we have two network in BGP table. Router 1 will advertise this network to router number 6. So to router number 6, let me show you the BGP table now. So BGP IPv6 unicast. So you can see there are two network in BGP table of router number 6. And if you will check connectivity, ping 2001 double colon 7, and source is, we can say, loopback 1. You can see there is connectivity as well, right? Means side 1 and side 2 of customer A are able to communicate with each other on IPv6 network, and in MPLS we are running IPv4 only, right? In service provider we are running IPv4 only. Okay, now let me configure the other side. Now it is very easy to you for you to configure other side, right? If you understand the configuration, like on router number 3, again we are going to enable IPv6 routing. Then we have created one VRF, RD value 1:1. We have defined RT value for IPv4 as well as for IPv6 100:100. Then interface 1/0 VRF forwarding A3. After that IPv4 address, then IPv6 address. This is IPv4 address. IP address between router 3 and router 8 is 38.1.1.0. Okay, and then router BGP 65,000. Address family IPv4 unicast VRF A3. For address family IPv4 unicast VRF A3, I have defined neighbor 38.1.1.8, remote AS 100, and AS override. Okay, and address family IPv6 unicast VRF A3, we have defined this neighbor remote AS is 100. This neighbor AS override and activate. As I told you that for IPv6 you have to activate the neighbor manually. Now let me copy this part of configuration here, R3 configuration, and let me paste this configuration in the console of R3. Here we have R3. So here also we don't have any error, right? That means all command is correct. Let me run the command on router number 8. On router number 8 configuration is exactly similar like router number 7 configuration, because on router number 8 also we are running both IPv4 and IPv6. So you can see interface fast Ethernet 0/0 have one IPv4 address and one IPv6 address. Then on loopback interface, again we have one IPv4 address, one IPv6 address. After that IPv6 unicast routing, the router BGP AS number 100. Router ID, here we can skip this part. Router ID is not required here. And then neighbor 38.1.1.3, IP address of router. This is IP address of router number 3, remote AS 65,000. And then neighbor, this is IPv6 address of router number 3, remote AS this one. And the neighbor network 10.1.2.0, mask is 255.255.255.0. This is for IPv4, right? And then address family IPv6 unicast neighbor IP address of router number 3 activate. And then finally network command. With the help of network command, I am advertising this network, right, which is running on loopback 1 interface. Here you can see on loopback 1 2001:8. So now let me copy this part of configuration here, router number 8 configuration, and let me paste on R8. Okay, now we are again expecting one BGP neighborship for IPv4 and one BGP neighborship for IPv6. You can see, right? And now here if you will check BGP table, so BGP BGP IPv4 unicast all, it have received, unicast only, it have received 10.1.1.0 from router number 5 from router number 3, 38.1.1.3, and this is self-advertised prefix. This is IPv4, and in the same way for IPv6, so BGP IPv6 unicast. So you can see in BGP table it have installed 3 network. This is self-advertised prefix, and these two are receive prefix from neighbor from 32001 db838:3. This is the IP address of router 3 on fast Ethernet 1/0 on this interface. Okay, so till here configuration is okay, and hope it is clear to you. Now finally let me configure router 4 and router 9. Router 4 and router 9 configuration is exactly same like previous video we discussed many times. On router number 4 you can see I'm creating one VRF, then I'm defining RD value and RT value, then uh, interface VRF, interface fast ethernet 1/0, VRF forwarding A1, then IP address on that interface only IPv4 address, then router BGP 65000 address family IPv4 unicast VRF A4 and neighbor 49.1.1.9 remote AS 100. This is IP address of router 9, right? And then AS override. Simple configuration. Let me copy this configuration, router 4 configuration, and let me paste this configuration in the console of R4. Okay, and now on router number 4, if you will check, so BGP VPN v4 unicast all, so it have received 10.1.1.0, 10.1.2.0, right? And for IPv6, it have not received any prefix because here we don't have VPN v6 between router 4 and router 5. Fine. Now finally we are going to configure last router number 9. Again you can see I have create one loopback and IP address on physical interface, and then router BGP 100 neighbor 49.1.1.4 is the IP address of router number 4 remote AS 65000, and then network command. Okay, so let me run this command on router number 9. Fine, that's it. Now we can verify the connectivity. From, let's say, router number 6. From router number 6 I am going to check the connectivity to site 2 2001:7, and source is, let's say, loopback 1. So yes, I am able to ping this side. Let me ping router number 8, site 3:8. Yes, I am able to ping this side also, and here we don't have IPv4, so let me take you to router number 7. On router number 7 we can ping 10.1.2.1, and source is 10.1.1.1. yes, there is reachability, and 10.1.3.1, 10.1.3.1, and source is 10.1.1.1. yes, there is reachability. So this is how we can configure 6 VPE. This is another method to configure IPv6 over MPLS. Okay guys, hope this video is helpful for you. If it is not clear to you, please rewatch this video. I'm damn sure there is nothing difficult. It is very easy to configure and to understand the concept. Okay, that's all for today. We will meet in next video. Till then, stay safe guys. Bye bye.